Hello and welcome back. So this is Sheng Yang, and he leads up Project Longhorn, Rancher's open source microservices-based distributed block storage solution. Yes, I'm reading that because it's a mouthful. But what's really cool is that storage is definitely one of the topics that we haven't yet covered today. So I'm really excited to have you on. Thanks so much for being here. And covering the really necessary topic of storage and how do you do it in a cloud native world. So with that, the floor is yours.
All right, thank you, Sonia. So let's get started. Hi, everyone. So my name is Sheng Yang. I'm a software architect from Rancher Labs. And today I will talking about our Project Longhorn, which is kind of probably new to even Rancher's users, but we have been working on this project for the past 4 years. So first, let's just revisit what is the cloud native. So this is the definition of cloud native in the Cloud Native Computing Foundation, CNCF. There's a bunch of words here, but I think the most important one is following 4. So the cloud native application first should able to be portable, which means the application you run, the application you wrote should be really cloud agnostic and should be able to run public cloud, private cloud, or hybrid cloud. It should not really depend on what bonding to the one cloud provider, like either it's AWS or Google Cloud or any private cloud providers. So that's portability. The second part is resiliency. As you know that cloud native applications are normally formed of the microservices, and on the premises that if one microservice is dead, this should be very quickly has a replacement and repair by itself. And that's the resiliency we're talking about. And the third point is elastic. So if you have the sudden traffic from the user and the high demand coming all in 1 second, you should able to scale your application either horizontally or vertically to meet that demand easily. And finally, we're talking about continuity. Because the cloud native applications form out of microservices, so it should be easy for the developer to do continuous integration, continuous development, CI/CD as we said, and publish the newest version and the greatest version to the user as quick as possible, but not suffering from the service down or any errors in the new version because you can do the rollback and the recovery very quickly as well. So I think that's the 4 core properties for the cloud native applications. But the cloud native applications are not stateless. They always have to be stored state in somewhere. Either it's storage, or you can put that in push the status in some like a third-party API like Amazon S3 or some other object store. But you have to form that API. So how is the storage handling the cloud native applications? If you are not pushing the stateless state of the application to a third party, you probably have to do that to provide the persistent storage to the applications. But there are challenges for the existing storage solutions. As the first one is the storage system is not really portable. For example, if you go on the AWS EC2, you're probably going to use EBS. And if you go on the Google Cloud, you're going to use persistent disk. That's 2 different things. And you're not going to write applications and run on both. And the second part is if you go with the private cloud, you're most likely going to buy some dedicated boxes like EMC or NetApp and use that for your cloud infrastructure. And lastly, it's also not easily portable to some other solutions or portable to the public cloud. The second point I want to make is the resiliency is normally good within the storage system because that's what the storage system do. The storage is probably the most critical part of your application, and nobody wants to lose data.
Sheng, I'm really sorry to interrupt you real quick. We're actually not seeing your slides. So if you don't mind resharing those.
Oh, sorry. All right. Okay.
Perfect. Thank you so much.
All right, so I was talking about the resiliency within the system. So storage system normally do very good on that, but it's not really easy to kill fail-safe copy outside the system. For example, if you are using Ceph, you know that Ceph is pretty good, do a good job, keep your data inside the Ceph system within the one cluster, but Ceph doesn't really have a way for you to backup the system, backup your data into someone else or export the data. So there's a bunch of backup products just written for Ceph to achieve these purposes. And the third point is Elastic is normally good with public cloud, but not so much with private hybrid cloud. So the public cloud, for example, if we are using AWS, you can always ask him for the EBS volumes if you as long as you pay for it. But the private hybrid cloud, if you are bringing new machines or starting new VMs, you normally need to do a bunch of configurations to make storage works, no matter what this underlying storage system is. And finally, it's pretty hard to achieve continuity since upgrades really need some downtime because normally the upgrade in the storage system going to interrupt your flow, interrupt your service facing the users. So you're going to see some maintenance downtime. So this is what we have right now for the existing storage solutions. So we're thinking that, is it possible that we can create a storage solution just in a cloud native way, write a cloud native storage solution that's powered by the cloud native infrastructure like Kubernetes, but also feed the functionality into the cloud native applications? That's how we come up with Longhorn. So let me talk a little bit about what's the details about Longhorn. So first, Longhorn is an open source cloud native storage solution. It's block storage. And because it's cloud native, we do have a lot of microservice to make sure that we have resiliency and easy to deploy and this kind of functionalities. It's very easy to deploy Longhorn in any Kubernetes clusters. If you are using Rancher, you can just do one-click deployment within the Rancher catalog apps. If you are using just any other Kubernetes cluster, you can check the Longhorn homepage, which is at github.com/rancher/Longhorn. And there's just one line of code, which is basically apply a Kubernetes YAML file to your cluster, which used it to create the Longhorn cluster. And it's always resilient. It's not only within the system, but also we have a built-in mechanism back up your volume to the S3 or NFS endpoint. So in that way, you should able to get the second system which act as a fail-safe if the Longhorn system or that cluster down due to any reason. So nobody should able to predict what is happening in the future. So it's better to be safe than sorry. And the fourth point is that the Longhorn itself scales via Kubernetes. What by that I means if you add Kubernetes if you add a node into Kubernetes cluster, Longhorn can automatically recognize that and use that cluster if you doing a certain per setup. And finally, Longhorn has ability to upgrade without volume downtime. Not 100% of the time, probably 95% of the time, but that is because the special structure we're using to implement Longhorn controllers. Okay, before I dive into the details of how the Longhorn was implemented, is there any questions? Okay. So for the Longhorn data plane, assuming that you have 2 nodes, and each one have a bunch of hard drive and the CPU and the memory. And you have container, which asking for volume. And the volume, and for Longhorn dude, is they were starting a controller and the 2 replicas, assuming that you want 2 replicas instead of 3 or 4 or 1. Normally people don't want 1 replica because that's not really resilient at all. So the controller will connect to the replicas, and the replica will be allocated into different nodes. And then controller will present a block device on the same host of the container is running, and the container will use that block device. In fact, the Kubernetes will format that block device into a file system and mount it for the volume to use as a persistent storage. So it's very simple, but you see that here, that if in the Longhorn model, in order to provide 1 volume, we are going to use at least three small microservices, 2 replicas and 1 controller. And as you may be able to guess, that this microservice, that controller and the replica are all packaged in the containers. So it's easier for us to deploy these containers into different hosts and form the necessary volume for the user. If you have a second container asking for volume, we'll do the same. And the third one still same. So on the data plane, the thing is very simple and clear. But what if but now you have the problem that how do we manage all these controller as replicas as a whole? How do we decide that, well, should I start the controller and the replicas? So that's how the Longhorn manager and the Kubernetes come into play. So imagine you have multiple volumes, which and only have 2 replicas per each volume. And notice that I changed the name and controller to the engine here. I will explain later. And is the Longhorn manager going to orchestrate all these controllers, all this volume, and decide what to do? The Longhorn manager itself is owning a connection of the controllers, which in the Kubernetes sense, and connect to the Kubernetes API server. All the state Longhorn manager kept about this volume as is kept into the Kubernetes API server and indirectly into the SAD. So if a Kubernetes want to create a new volume or do something about that volume, they will talk with Longhorn through the Longhorn CSI plugin using the CSI interface. And the CSI is a container storage interface, which is the standardized spec for the container infrastructure, container orchestrations, like Kubernetes, Docker, Mesos. They're all going to follow this standard. So the Longhorn CSI plugin will talking the Longhorn manager through the Longhorn API and perform the necessary works. We also have a Longhorn volume talk to the Longhorn manager using the Longhorn API to perform some operations that Kubernetes cannot do, like take snapshot backup and set up the node, doing some configuration, and scheduling the backup and the snapshot for a certain period of time. Okay. So here is give a quick example of why Kubernetes, we say that Longhorn is the cloud native and Kubernetes native controller. And here I show that what is Kubernetes controller pattern. If you know that Kubernetes controller pattern is sometimes people call it operator pattern, is the continuous reconciliation between the spec and the status. The spec is what's user defined of what's the status you want to get, and the status was the observation of the current status in the system. And here on the right, I have a volume defined as 3 replicas, and the current status, we have 3 healthy replicas, so nothing we need to do. And the engine itself, they have a replica list, they have 3 replicas there, and the status, all 3 replicas are in the green, which means they're healthy, so nothing we need to do. So here we'll demonstrate that how Longhorn decide to rebuild 1 volume using this information. First, assuming that node 3 is down, and the engine will immediately detect the node 3 and the replica 3 is down, the connection will become red. And the Longhorn manager see that the engine reports the replica as red, and the Longhorn will remove the replica 3 from the replica list. So the connection between the engine and the replica list was disconnected. But now we only have 2 healthy replicas, but we want 3. So Longhorn manager will asking engine to start rebuilding a new replica and node 4. And node 4 will be added into the engine spec. And the engine will see that and starting rebuilding the replica 4, which is showing as yellow here. For now, the current healthy replica is still 2. After rebuild was done, the engine will report that the replica 4 now become healthy, and the Longhorn manager will see that and update the healthy replica to 3, which is match what we expectation. And now the resiliency of the engine of the Longhorn volume has been restored. All right, next I'm going to do a demo to show you how Longhorn works. All right, let's Okay, so now I have 2 questions coming. One is coming from Michael. How does Longhorn compare to the Podbox? So by first, Longhorn is open source product, and Podbox currently is closed source. And I haven't have much experience with Podbox, but I think on the stable, but I think they have been prototyped earlier than Longhorn, so we're playing a catch-up game. But in fact, because Longhorn is open source and we do work on a lot of users to try, and I have tried the Podbox once. It's not really easy to set up and locally, but I'm going to show that how easy is it for Longhorn to set up. So I think that will give us some differentiate. And how Longhorn is different from Rook. So in fact, the Rook is from Rafael Launder. So the Rook, in fact, is not really a complete solution as the storage system. The Rook is basically orchestration Ceph and trying to migrate Ceph in the cloud native environment. There are many things Rook can do, but the Rook doesn't own the stack from the bottom. The Ceph build, I have to admit, Ceph built a very good foundation, but the Rook for itself, Rook's role is more like the Longhorn manager, which is going to decide well to schedule the Rook instance and we schedule the Ceph instance and all this kind of management operational stuff. Okay, so let's start the demo. So can you see my screen?
Sorry, was getting off mute. Yes, we can.
Oh, okay. All right. So now I have currently running a Rancher instance. I'm going to just going to deploy Longhorn right now. So I switch to the system project, click catalog app, and I'm going to launch Longhorn. I'm going to show that how Longhorn going to upgrade without interrupting the workload. So I'm going to choose a slightly older Longhorn version now. All right. So in fact, it's very fast for Rancher to detect that it's still upgrade available. And for now, we just wait for Longhorn to deploy. Okay, I think the driver is not ready yet, but they will be ready very soon. Okay, should be fine now. Okay, now what you see is the Longhorn UI. So for the dashboard, we can see that how many volume we have right now and what's the storage we can use on the node. By default, Longhorn is using is co-located with your root disk, and using some directory on the root, you utilize it as part of storage. But you can reserve part of storage for the root disk in order for Kubernetes and the operation system to use. So that is what we have here. And we have 3 nodes there, all of them green, and also we have event log in between. On the node page, you can see that. So currently we're using the var lib rancher Longhorn as the place we're going to store the data. But you can do add it in the disk. If you want to add any disk, just format the disk, mount it on the root, mount it on some place in the node, and put the path here. Longhorn can detect that how many storage we can use in that disk. Same for all other nodes. We currently doesn't really have a volume right now, so the volume page is empty. So this is now I'm going to show you how to set a backup target. As I mentioned, backup is a very critical feature of Longhorn, so we do recommend that every user should set a backup target. And we also have attached in our document, we also shipped one testing backup store here with using the menu, and you can just set up it using this one line command. I'm going to do that in the Kubernetes. All right, I think most of them, I think I already set up them, so it's the arrow on the existing. So the backup target, after you run this and set up the menu backup store, I'm going to set up backup target and oops. Here and click save. Now we can click the backup. You see that we don't have any backup right now, and we don't have warning. So but we don't have error message, so that's fine. So for the next step, I'm going to show you how you're going to use Longhorn. For now, I'm going to use the example from WordPress. That's common things. And we want to MariaDB and WordPress to use persistent volume. And in fact, the default storage class right now is Longhorn, so you don't need to choose this, but just in case. So I'm going to launch a WordPress instance with Longhorn. So in fact, I can take a look at the dashboard here and waiting for the command to the Kubernetes calling to Longhorn to start these volumes. Now you can see that there are 2 volumes flash up, and they are in the progress to being attached. Look at the volume page. They're doing attaching. It should be there very soon. And the endpoint is show means that's attached. Let's take a few seconds for them to detect that what's the status of this volume. Once you have volume in place, the WordPress will continue to deploy. And now I want to show you that what is the UI of the detailed volume page. So as you can see now, so we have by default 3 replicas running on 3 different nodes, demo 1, 2, and 3. And because we have set up the backup store, we can just create the backup. It'll take a while. And for the backup, we're going to take snapshot first and put that snapshot in the backup store. The difference between the snapshot and backup in the Longhorn is snapshot is existing within the Longhorn system, but the backup is Longhorn copy that what's the content of that volume or snapshot into a third party like S3 object store on FS server. And here you can also set in the recruiting snapshot backup. If you want to have your volume backup every day or every hour, you can set up here. Let's see if WordPress is up. All right, the WordPress is up. Everything looks good. So let's log in. Write something about it. publish, and just make sure that it's stored. Okay, so now I'm going to demo what if one node is down. By similar that, I'm going to just delete the replicas on any random node. I'm choosing demo 2, but you can do that for the demo purposes only. You can do that on any node. So the volume, because the replicas are down, so the volume is not in healthy state, they are degrading. So, and the volume is started rebuilding, as you can see here. But in the meantime, the WordPress still functioning well. Nothing really changed, right? It takes some time to rebuild. Okay. All right, now the rebuild complete. And the volume become healthy again. And WordPress is as good as always. So now I'm going to show that how easily it is for user to upgrade a Longhorn. Because we are built upon the Kubernetes and cloud in the cloud native way, it's really easy to upgrade. In order to upgrade, you can, in fact, from Longhorn UI, if you notice, here is a green arrow shows that Longhorn 0.3.3 is available, and currently we're running 0.3.2. After you receive that notice, you can head into the catalog apps in the Rancher and click upgrade. And this will upgrade the Longhorn manager, but the Longhorn engine, because it's still running, will still run on the old version. But we'll deal with that very soon. Well, I don't believe this be so quick. Really? Yeah, that's right. So you can see that the new version has been deployed, the old version has been deleted. And I think it's probably ready now. No, not yet. Let me see if you are. Okay. So now UI is showing 0.3.3, which means our upgrade of Longhorn Manager works. But because the volume currently is running, we don't automatically upgrade the volume image. So you can see that in the setting, the engine image, they have the old version, which is 0.3.0, which is used by 0.3.2 manager as well, and the new version 0.3.3. So now we are going to upgrade these two volumes while the volume is still being used. And we just click upgrade engine here. We want to use the newer version, and we click OK. We probably want to upgrade WordPress as well. So I just click please upgrade now. Update now. And this part is upgrade. Oh, I think it's already complete. Let's click. Okay. Let's see. What's the version? Doesn't show here. Check again. Seems WordPress doesn't really want to upgrade. But Longhorn itself is upgraded correctly. Let's upgrade this one as well. That's the second engine we want to upgrade. Let's see. Updates. Check again. Well, WordPress is okay. Let's upgrade plugins. Oh, now here. Okay, I think WordPress finally completed the upgrade. All right, 5.0.3. Now the WordPress is upgraded and the Longhorn itself is upgraded. We are all using the latest version. So for the next, I want to show you that how Longhorn is scaled with Kubernetes. You see that cluster demo, we have only 3 nodes. I just click on and create 4 node. And now the branches we're asking RKE to provisioning a new node. And the Longhorn doesn't have anything yet, but now we can also try that to do this recurring backup because our data is important. We're doing the backup every minute. Return 5. Now doing backup every minute. Return 3. Okay, let me see if how the backup goes. Oh yeah, right. So that's how you configure the backup. Let's say the provisioning here is still provisioning the new Longhorn version. So I can answer a few questions now, I think.
Okay, awesome. Well, thank you so much. This was great. I love the fact that we did get to cover storage as part of the cloud native space, and we'll look for more things coming out of Longhorn and the Longhorn project. And I think it's super exciting. So thank you so much for being with us.
Thank you, Sonia.
Thanks.